Welcome back to my channel. In this video, we are going to learn how to optimize the input file of silicon. The idea is that once the input file or the structure of silicon is optimized, then we can go ahead to compute properties like the mechanical property, structural property, the lattice dynamics, the optical property, and so on and so forth. So let's get started. So we've prepared the folder for silicon, so I'm opening it. Now this is the input file for silicon. Now from this file we have the atomic position, we have the K points, we have the E cots, we have the pseudo potential, and the other things are just normal things that one needs to know. Now the three things that we need to optimize in any input file is this one, the E cots, followed by the K points, then finally the lattice constants. Okay, so some persons, they prefer to optimize this one first, the K point first, followed by E cots, then finally this one. But anyone you use, it's okay. So let's start by optimizing this one. To optimize this value, right, what we want to do is to look for the value that will give us an accurate result for the shortest time. Because if we take a value that is too small, it might not give us accurate results and it will run fast. And if we take a value that is too much, too high, it will take much time to run and it will be accurate. So what's the idea of the optimization is to look for a value that will not take too much time and will also be accurate. So to do that, we'll use a script. We can copy this one we'll copy it, minimize, and open this one. This one is to optimize the E codes, this one is to optimize the K point, and this one is to optimize the cell dimension. So I can open this one, and what I need to do is just to paste it here. Now this particular stuff will replace this one here. Then we can, this silicon, I can change this one to silicon, right? So I want to start my optimization from, let's say, 40, then 45, 50, so it should end at I want to end it at 70. Okay, so this is a script that will do just that. So this script will run 40, will put out the results, will come back and run for 45. It will change this one to 40, run it, put 45 here, 50. Once it is done up to 70, the calculation will stop. Then at the bottom here, what we have is that there are certain parameters, certain things that we need from the output file, this output file, which will be extracted, and that's from the kinetic energy, right? Then it will send everything into E codes. I think here it's supposed to be alert. Okay, so we can go and run it, and let's see how it can be run. So from here, I'll open my terminal. I'll cd into silicon. Then to now run it, I'll use sh create. Then I'll click enter. So it's running. Once it has finished running, it will be extracting what we need into the E codes. You can see E codes is already out. If we open it, this is the E codes for 40, and this is the corresponding total energy. Okay, so it has run for 45. You can see the 45 here, and that's how it will run and until it finishes. Okay, so we can see that it has finished running, right? So we can go and check our E codes, and these are the parameters from 40 to 70. So the question is, how do we know which of them is the optimized value? To know, we can come to our terminal and use a command to determine. So what we want to do is to subtract this one. We'll subtract this value from the first one here, subtract this last value from the second one, this last value from the third one, and continuously. Okay, so the command to do that is awk so I'll come and copy this one. I'll copy it and I'll paste here. When I'm pasting here, I'll use Ctrl Shift and paste. So $2 here means this everything here should subtract. This value should be subtracted from this. But remember, when you are subtracting, it will now be minus minus, which is plus. So I'll come back and change this one to plus. Then now I'm done. So it will pick this value, but it needs the file where it will pick all this value from. So the file name is equals. Then I can click enter. So we can see that these are the values. You know, when you subtract this from itself, it will give you 0. So that's why this part is 0. So we can see that all the values are up to minus 0 times 10 raised to the power minus 5. Meanwhile, the accepted optimized value is within the range of times 10 raised to the power minus 3 or times 10 raised to the power minus 4. Since all of them have times 10 raised to the power minus 5, we can pick this one as our optimized value. Since this one has times 10 raised to the power 5, and what you should watch out for is the one with times 10 raised to the power 4. But if there is any value times 10 raised to the power minus 5, 6 is okay. We should avoid times 10 raised to the power minus 2, times 10 raised to the power minus probably 3. We should just stick with 4. Okay, so since this one has all of them, they have 5, we can pick 40. Okay, so we move down to this second one. I'll open this second one. This second one is to optimize the key points. So I can come here and pick everything here and open this one, which is a second script for key points. Then I'll paste here, and once I paste, I'll delete everything here. Okay, so since we have selected 40 as our optimized value, we'll keep here as 40 permanently and save it. Okay, so I'll still come back and change this one to SI. Then we are going to start from 6, probably let's put 5 to 11. Then everything is intact. Then what we want to optimize is our key points. You can see this value, this value, this value. We used to have 888, but now it will take this 5 and put here 555. It will optimize it, give us the total energy corresponding to 555. Then pick 6 and put inside here, optimize it until it gets to 11. So once it gets to 11, we'll go and check the output file. So let's run it so we can save and run. So to run it, we just recall and change this one to 2. So we can see 5 is out, the corresponding input file for 5 and the corresponding output. That of 6 is out, the corresponding output. 7 is out, 8 is out. Okay, so from what we have on the terminal, it shows that the calculation has finished running, which is up to 11. Now, the way we optimize our E-codes, the way we extracted the E-codes is different from that of the key points. So we can manually extract our values from these key points. So what we need to do is to use grep and use this exclamation, then the name of each of these files, silicon.scf. Since we have numbers in front of them, we can use star to recognize the star. Then we click enter. Okay, so these are the corresponding total energies for each of these key points, right? So we can check by optimizing. We can check the optimized value just by looking at this is the last term here. Another way we can do optimization is to pick the last 3-digit number 193, and once we pick 193, we check upward and see where the 193 ends. So if you see 11 has 193, 10 has 193, 9 has 192. So because the 193 ends at this point, I can pick 10 as my optimized value. 10. The reason why I'm picking this one is because by the time I subtract this one, this last term from this, I'm going to be guaranteed with times 10 raised to the power minus 4. Okay, so with that, 10 is my optimized value. I'll come to this last one, right? Then I'll pick this my SCF and enter here and click paste. So if you recall that this one, the optimized value there is 40. The optimized value here we've agreed to be 10. We'll save it. Then this is my cell dimension. Then that's what I will now put here. Then I'll remove this one and put inside of this place. Okay, so from the way it is now, we are going to subtract 0.1, 0.2, 0.3 from this value and add 0.1, 0.2, 0.3 from this value and add it to this value. So that's how to get the optimized value. Okay, so with this one, everything should be set. But then before we start running, we need to delete all these values, all these files. We need to delete them. Then so now that we have this, okay, this one is not necessary. This one is not necessary. Okay, so this is a script that will do that for us. So the stage we are in now is to do this optimized cell dimension. So at the end of the day, as it runs, it will extract the total energy and send it into alerts. Then it will now ask for ev.x. That's the executable file needed to get the optimized value. So let's run it and see how it goes. So we'll come here and change this one to 3 and click enter. Okay, although we didn't remember to change the SI and the SI, but let's see what comes out of it. Okay, so from the way it is now, it has finished running, and these are the corresponding. This is a file that it extracted, this one and the total energy, right? So I can close this one, then close this, and close this. So this is what we have as our final lattice constants with the corresponding energy. So from the terminal, it is asking us we should put the lattice parameter, whether it is in volume or the lattice parameter, and whether the unit is AU or Armstrong. The unit is AU, so put AU and click enter. It's asking what type of driver is lattice. It is FCC. Silicon is FCC. You must know all these things before now so that you can use it to complete this one. So you are asked to pick any equation of states. You can pick 4, you can pick 1. I like picking 2. No. I like picking 4 for simple compound, Y2 for complex compound. So then the input file is alerts. Then the output file can be anything. So I like using a.out. Okay, so this is the alerts that we generated. And from this alert, we can see that the optimized value is this compared to what we started with. Let's go and check. What we started with was 10.26 and the optimized value is 10.33. So this is our own measured value compared to where we got this one from, probably from literature. Okay, so in this same file you can get your bulk modulus, you can also get your pressure derivative, then the minimum energy if you need it, then the volume of the lattice constant in case you need it. This one is in Armstrong while this one is in Bohr. So that's how to optimize. So once you are done, you can copy this one now and put it inside your SCF file. We can call this one SCF file and put inside of this place. So we'll save. So now this file now contains the optimized equals, optimized K point, and optimized lattice constant. Whatever other calculation you wish to do, like the elastic constant, the phonon dispersion curve, or the optical property, you can now use this file because you are assured that this file will give you the ground state energy of this compound. Thank you. Hope this works. Please like, share, and subscribe to my YouTube channel. Thank you.